Next, we're going to introduce the concept of integrating vector-valued functions. So to integrate a vector-valued function works very similar to what we saw for the differentiation of vector-valued functions, which is, if you're interested in integrating a vector-valued function, this is the same as taking the integrals of each of those individual functions, the component functions that are inside of the integral. Now, in the event that it is an indefinite integral, like the one that you see here, each one of these three integrals will get a plus c associated with it. Now, plus c in vector form will need three distinct c values for these. Me personally, I like to refer to them as c1, c2, and c3. However, if you wanted to refer to this vector as plus a constant vector, that would work as well. Now, we know from back in Calc 1 and Calc 2 that the significance of an antiderivative, the significance of an indefinite integral is that it is the antiderivative. The antiderivative of r. Now, if you're interested in doing a definite integral from a to b of r of t dt, then that will be take the definite integral of each of your component functions as well. Now, for the time being, it's more important that you know how to do it than what its significance is. Much as I would love to say the definite integral represents the area below a space curve, that's simply not the case. However, these will have a use once we get to some more advanced vector calculus later in the semester. So for the time being, I just want you to know how to do it rather than exactly what we're going to do with it. We need to practice some more skills before we are able to get to that point.